Okay, let's learn about the basics of conic sections. And conic sections are curves that result from the intersection of a plane and a double cone. And hang on a minute, and I'm going to show you a demonstration. All right, so you can see I got two red cones here, and I've got this plane right here. And right now, the intersection of this plane with that top red cone is a parabola. Can y'all see that? Okay, and here is a representation of it over here. And then if I change the tilt of the plane, now it becomes what we call an ellipse. And then it's a circle when the plane is flat. And if I make the plane vertical, I get a hyperbola. Okay, so the basic types of conic sections we have are hyperbolas, ellipses, and parabolas. All right, so let's look at parabolas. A parabola is a set of all points that are equidistant from a line and a point. All right, what that means is if I pick any point on the parabola, the distance from that point to this fixed point and that point on the parabola to the line should be the same. Those are the same distances. This point is called the focus, and this line is called the directrix. So the set of all points that are the same distance away from a focus as they are from a directrix, those points make up a parabola. Okay, an ellipse is a set of all points, the sum of whose distances to two fixed points called foci, that's the plural of focus, is constant. So if I have these 2 points right here, and this distance plus that distance is the same, no matter where I am on that curve, then that curve is called an ellipse. So if D1 plus D2 equals D3 plus D4, and if I pick another point, say right here, that distance plus that distance, they're all going to equal the same constant. That makes an ellipse. A hyperbola is similar to an ellipse, except instead of the sum of the distances to the points, it's the difference of the distances to two fixed points. Okay, so here's one focus right here, here's another focus right there. So if I'm on the curve of the hyperbola, then that distance there minus that distance there, actually the absolute value of that difference. So the absolute value of D1 minus D2 will equal the absolute value of D3 minus D4. So that makes up what we call a hyperbola. All right, so what kind of equations give us ellipses, hyperbolas, and parabolas? Well, we have what's called a general form of a second degree equation in two variables, and we usually use the letters x and y for our variables. So what we have is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And it's got to be in that order. X squared first, then your xy term, then your y squared first, then your y squared third, then your x, then your y, then your constant. Okay, so how do we know what we're graphing if we're given that equation? If b squared minus 4ac is negative, we get an ellipse. If b squared minus 4ac is 0, we get a parabola. And if b squared minus 4ac is positive, we're going to get a hyperbola. So let's take some equations and see what kind of conic section they would give us. Okay, so here a is 1, that's the coefficient of the x squared term. B is negative 2, that's the coefficient of the xy term. And C is 1, that's the coefficient of the y squared term. So b squared minus 4ac is going to be negative 2 squared minus 4 times 1, which is 0. And remember that if b squared minus 4ac equals 0, we get a parabola. Okay, how about this equation? Well, let's rewrite it in the correct order. So we have negative x squared plus 2y squared minus 16 equals 0. A is negative 1. B is 0. Remember, b is the coefficient of the xy term. And c is 2. So b squared minus 4ac is equal to positive 8. That's greater than 0, so we are going to get a hyperbola from that equation. And finally, let's look at this equation. A is 1, B is 0, and C is 0. Remember, B is a coefficient of the xy term, C is a coefficient of the y squared term. We don't have an xy term or a y squared term. So b squared minus 4ac is 0 squared minus 4 times 1 times 0. That equals 0, so we have another parabola from this equation. And that's all you need to know about conic basics. Given a second degree general equation in two variables, what kind of conic section would they generate?